Hey guys, we're going to look at installment buying, which just means making monthly payments, and we'll calculate what the payments would be. So this is, if you actually go into banking or anything like that, you will actually be doing this. Although they do have some computer programs and things that do it for you. So there's a fixed installment, which means like what you would do with a car payment. You set it up, you figure out the purchasing price, and then figure out the amount that will be paid every single month for 60 months or 72 months or whatever, 5 or 6 years, depending on what they set up. Or there's open-end installment, like a credit card, and your payments can vary and stuff like that. APR, the annual percentage rate, that is the true rate of interest charged for the loan, and then finance charges are all the fees that are charged, interest and any other charges that there might be. For example, some credit cards have like annual fees or late fees and things like that. So those would all be parts of the finance charge. Missed payment fees, those are all sorts of things that you would see. So the total installment price is the total amount spent, includes monthly and down payments. So that's like what you would actually pay if you totaled up all of your payments for the entire life of the loan. Then APR formula right here. The finance charge over the total borrowed equals the table value over 100. So here's that table. So Kristen wishes to purchase some new window blinds for her house at a cost of $1,500. Home Improvement Store has an advertised finance option of no down payment and 7% APR for 24 months. Determine the finance charge. So we're going to do a couple of things here. We are going to start with getting the value from the table. So we're going to look at 24 months, and 7%. So we're going to take the 7%, 24 months. We're going to see where they meet. That's right there at 7.45. So that's our table value. So from our equation on that previous slide, table value over 100 equals the finance charge over the total borrowed. So finance charge is what we're solving. Over the total borrowed is the $1,500, because there's no down payment, nothing like that. Then we do the table value over 100. So this is now as simple as cross multiplying. 100x equals 7.45 times 1,500. And then we will divide by 100. It's $111.75. So that is the finance charge. That's all the fees and everything. That's how much, so fees, interest, everything. It's going to total $111. So to determine the monthly payment, that's what that's in addition to the cost of the loan. So it's the 1,500 plus the 111.75. And then this was split up over 24 payments, so then we just divide by 24 to figure out what every payment will be. So the 111.75 will be the total of the total amount of interest that's going to be charged during that, and then you divide by how many payments. So we add the 1,500. I did that by hand already, but we'll do it on the calculator. And then divide it by 24 payments. 67.16. So you have to make 24 payments of $67.16. And that will be a total of the $1,611.75. So by not paying cash, you end up paying that extra $111.75. If you would have just walked in there with cash, you would have got it for, you would have saved $100, $111.75. All right, Benjamin wants to buy a new car that costs $20,000. He paid 15% as a down payment and financed the balance with a 60-month installment loan with an APR of 8%. So we need to figure out first how much that down payment is. So 15% of the total cost is how much he did in down payment. So 15%, 0.15, times the total cost of $20,000. So that means his down payment was $3,000. Which means he's going to finance. Oops, I missed a letter in there. Finance the rest of the $20,000, which is $17,000. With a 60-month installment loan with an APR of 8%. So we find 8%, we find 60, 21.66 is our table value here. And then we do table value over 100 equals the finance charge over the amount. And again, that's just from our formula. Table value over 100, finance charge over the borrowed amount. Now we will cross multiply. Now 100 times x, we're going to end up dividing by 100. So if you just want to take this 1,700 and multiply it over, or 17,000, and multiply it over, that works. And then saving some button presses, this 100 is just going to cancel 2 zeros. So we don't have as many buttons to push. It's 170 times 21.66 from our table. 3,677 and 10 cents. So that's how much we are paying in interest over all that time. So to figure out the monthly payment, you add it on to the 17,000. So that's 20,677 and 10 cents. And then we're going to divide it by the payments, which we said was 60 months. So we add, we did it by hand, but again, we're just doing it now on the calculator. 17,000 to get the 20,677 and 10 cents divided by 60 months, 60 payments. Each payment is $344.62. Jan is purchasing a new boat for $25,000, including taxes. She decides to pay $5,000 down and finance the balance at $20,000. Just doing a subtraction there for you. The loan officer informs her that her monthly payment will be $410.33 for 60 months. Determine the finance charge. So, finance charge over the total borrowed equals the table value over 100. That's our first formula. But we don't know the table value either. All we know is 60 months. We don't know the APR, the annual percent rate. So, can't use that formula. So we need to think backwards a little bit. We can look at the final step that we did in all of these was you add the 20,000 plus the amount financed. And then you divide it by the number of payments, and that was our monthly payment. So that's going to equal 410.33. So the 410.33 times 60 means that over those 5 years, it'll pay a total of $24,619.80. So that equals the 20,000 plus X, which means that subtracting the 20,000, the finance charge is that $4,619.80. That's how much it costs to have that loan instead of paying cash. So now we have all of this. Now we actually know this 4,600, that was X, which goes into this part of our formula, which we wrote down to begin with. Oh, I didn't mean to write APR there. That's the table value, not the APR value. So we can now do our division by 20,000 multiplied by 100. Need to subtract the 20,000 from this. Divide by the 20,000 from our formula in the top left here. Multiply by 100. And this will tell us our table value is 23.1. So the table value is 23.1. We know it was also 60 months. So we are looking in the bottom row. And we said that that number from the calculator is 23.1, which is right there, which means the APR is 8.5%. So that's working that backwards, but it works out the same way. Works no matter how you need to use it. You just got to use the formulas and think through it. Thomas borrowed $9,800 to purchase a classic Ford Mustang. He doesn't remember the APR, but remembers that there were 48 payments of $237. He did not make a down payment to determine the APR. So 48 payments of $237 means that the total amount paid is $11,376. He said he only borrowed $9,800, so we can subtract the $9,800. Which means that the finance charges were $1,576. So now we are going to take that finance charge, just like we did in this last example. We knew the finance charge. And then we set it up into our equation. So we take that finance charge over the amount borrowed equals the table value over 100. So 1576 divided by 9800 and then multiplied by the 100. Tells us that the table value is 16.08. And the other piece that we do know is the 48 payment. So we're looking in this row for 16.08. Basically right there, 16.06. So it's 7.5% interest. Unearned interest is the amount of interest saved by paying off the loan early. And then the actuarial method for unearned interest. This is actuarial. One of the most math-driven professions is called an actuary, and this is what they do. They just work with loans. They work with insurance and all that sort of stuff, and they make all these calculations. And I believe that's pretty well-paying job because you have to have a lot of math skills to be able to do it. So I actually know at least one teacher that left teaching to become an actuary and make more money. So I just do not want to do that. So here's the formula for it. Unearned interest is R. N is the number of remaining payments. P is the monthly payment amount, P for payment. V is the table value. And then you just have to plug V in two places and everything else. So Ray took out a 60-month fixed installment loan of $12,000. He paid no money down and began making monthly payments of $232. Ray's business does better than expected, and instead of making his 24th payment, Ray wishes to pay his loan in full. Determine the APR on the loan. So that's the first part. So we know that there's 60 months. We know $12,000 with no money down. And the payment is $232. So 60 times 232. Figure out how much money he was supposed to pay. Would be a total of, I forgot what it said, $13,920. Minus what the loan was supposed to be for $12,000. So that's $1,920 when we subtract. That's our finance charge. So to determine the APR, we're going to use our table kind of backwards. So we know that we do the finance charge over the total amount that was borrowed equals the table value over 100. So we're going to multiply by the 100, cancels out 2 zeros there. This 0 cancels out that 0 also, saving some button presses. 192 over 12. So our table value is 16. And we also know that this was set up for 60 payments. So we're looking in the bottom row for a table value of 16. So the APR is 6.0%, 6%. How much interest will Ray save by paying off his loan early? So we're going to use that formula from the previous slide. NPV over 100 plus V. And that's going to equal unearned interest. So the unearned interest is the amount of interest that Ray's going to save. So now we're looking at N, and if we go back and look at these definitions, N is the number of remaining payments. P is the monthly payment, we know that much, and V is table value from the number of remaining payments. So for both of those, we got to figure out how many months are left, which is easy because it said it was going to be 60 payments, and he's paying it off on the 24th payment, which means he's saving 60 minus 24 is going to be 36. Whoa, what happened? 36 payments. That's N. Times the monthly payment, which it told us was 232. Times V, which is going to be from our table. We're going to plug that in both spots right here. So V has to use that 36 months that we just calculated, the number of months that he's shortening his loan by, and we're going to take that 6% still. 36 months, 6%. V is going to be 9.52 in this step. $9.52. So we plug that into our calculator, 36 times 232 times 9.52 divided by 109.52. Little mental math there. $725. It's actually going to round up to $726. So for this last part, calculating the payoff amount. So you figure out, we're going to figure out how much he would be paying over those 36 payments. So 36 payments of 232, he would be paying $8,352. But he's saving the $726. Which is 7626. So that is the payoff amount. because instead of paying 36 payments of $232, which would be a grand total of $838,352, he saves that $726 by paying it off early, and he does not have to pay that, so you just subtract it. Now, there's one part that I kind of forgot about there, is remember he's sending in the payoff with his last payment. So with that payment for the 24th month. So that's in addition to the $232. So that's $7,858 total. So when he sends in that check to pay it off or whatever, he needs to send in the $7,858. All right, so we're going to look at a credit card example, an open-end installment loan. So Mary's credit card company determines her minimum monthly payment by adding any new interest owed to 1.5% of the principal. And then they charge per day interest rate. So on Mother's Day, May 17th, which, fun fact there, Mother's Day cannot happen on May 17th. Go ahead and you can look into that one if you want. Mary used her credit card to purchase, so I guess maybe that's why she got such a nice gift, is because it was a late Mother's Day present. That's why she bought her mom a TV. So a $1,500 TV for her mother, and then she made no other purchases. So the principal then would be $1,500, and it says that there's no interest here. Usually not in that first amount. They calculate interest after that, but so on June 1st, her billing, no interest yet, except they will calculate the 1.5%. So multiply that by 0.015, 1.5%. So that's $2,250. So their minimum payment then is just based off of that you have to pay 1.5%. That's like their minimum payment calculation for this. So the minimum payment would be $2,250. Now, typically they would round that up. They don't send you minimum payments on your credit cards for change. They would round that up to like $23, but so that's about what the minimum monthly payment would be. Now just keep in mind that this paying only 1% means that it's going to take you, I mean, it's 1% plus interest. So it's going to take, if you pay minimums on your credit card like this, it's going to take like 100 months to pay it off, which is years and years and years, usually over 100, because just the way it's going to work out with interest and everything. So that's why minimum payments on credit cards is not the best idea. So on June 1st, instead of making the minimum payment, here she goes. She's being smart. She's not making the minimum payment. She's paying $200. And assuming there's no additional charges or cash advances, good. She's just going to pay off her credit card without adding to it. So if she paid off $200, that means now she owes $1,300. And no additional charges or cash advances determines Mary's minimum payment due on July 1st. So there's two parts to figuring this out. First, you would figure out what the 1.5% would be. So we're going to multiply that by 0.015. And that would be the minimum payment that she would have to make on the principal amount. So that's $19.50. Now remember, they would round that up, but that's also not factoring in any interest, because now they're going to start charging interest on it. Remember, our formula for simple interest is interest equals principal times rate times time. So they're going to add whatever the interest charges would be on top of that to figure out your monthly payment. So principal times rate and then times time. So the rate is calculated per day, which, just for fun, real quick, we've talked about some of these loans. We're going to take the 0.04792%, so it's going to be 0.000472. That's it as a decimal. Point 0.0004792. Now, since that's the daily interest, just wanted to multiply that out times the full year of 365. So that's like 17.5% interest per year, which is pretty high. It's typical for credit cards, but that's a lot. You don't want to be paying that for a long time. So it's principal times rate times time, and this is the month of June, which has 30 days. So we will multiply that out. By the way, what I just did right here, you can work that backwards. So if a credit card company tells you, I've seen as high as like 29.99% interest per year. Sometimes they'll say that. So that's percent, so divide by 100. And then divide that by 365. That would be your daily interest rate. It's going to have 3 zeros on it, just like this one did, and 821. So that's how you can figure out what that would actually be, what your daily percentage rate would be. Just divide the annual by 365. But that's not what we're doing right now. We're just multiplying out this 1,300 times our daily interest rate times 30. So that's $18.69 in interest, and they're going to tack that on to what you would have to pay towards your principal, interest plus principal. Now you're paying $19 in interest and almost $19 in principal and almost $19 in interest. So we need to add those two together, the $19.50 plus 18.69. And that would be your minimum payment. Now, no matter what, you're paying the $18.69. Hopefully, you're going to pay more than the $19.50 towards the principal. That's the minimum principal, though. That's what this is saying is minimum payment. It's $38.19. And again, I told you in that last example, $38.19. They're always going to round that up. So it's actually going to be a $39 minimum payment. All right, that's it. Complete the worksheet that's in the tabs, or the file tab of our class teams page, and then get that submitted to me through Student View.